In this video, I want to have a look at how we can calculate areas that are bounded by the y-axis. So far, everything that we've done has always looked at regions that were bounded by the x-axis. So now we're going to have a look at it the other way around. So to do that, we need to evaluate our integrals with respect to y instead of with respect to x. So just a reminder what we've been doing so far. If we have a function, f of x, and we want to find the area between a and b. So we want to find the area of this region here. What that looks like is this. So we've got the integral from a to b of y dx. Now often instead of that y we've written f of x, and sometimes we have a function like f of x equals x squared or x cubed or whatever it happens to be. But we know that we could also write that as, say, y equals x squared or y equals whatever the function is. So we can have our y and integrate it with respect to x. What we're looking at now instead is if we have a function and we want to find this area here, pretend that's horizontal, so that's our a value, this is our b value, and we want to find this area here. So it's bounded by that y-axis, not the x-axis. So we're going to integrate between a and b, so a and b are now our y values that form the boundaries of x dy. So let's have a look at how we do that with an example. So our example asks us to calculate the area of the region bounded by the curve y equals x squared, the y-axis, and the lines y equals 1 and y equals 4. So the first thing we want to do is draw a sketch to see what this whole thing looks like. So we'll draw up our axes. We'll draw in our function y equals x squared, which is just a parabola with a vertex at the origin. Now we also want the lines y equals 1 and y equals 4. So 1 is going to go across here. That's y equals 1. And y equals 4 would be up here somewhere. And I forgot to label this one as y equals x squared. So what we're trying to find is bounded by the y-axis, those two lines and our curve. So it's this region in here. So to find that area, we have the area is equal to the integral between our bounds. So that's our y equals 1 and y equals 4. So between 1 and 4. And now we want our function, but we don't want our function written as a function of x, we want it as a function of y. So at the moment our function is y equals x squared. We want to rearrange that to make x the subject. So we're going to have x equals, to get rid of that squared we'd have to square root, so we'd have plus or minus the square root of y, or plus or minus y to the power of a half. Now we only care about this positive side of things, so because we're only looking in that first quadrant, we're just going to look at the function x equals y to the power of a half. So we're going to have y to the power of a half, and we're going to integrate that with respect to y. So when we do that, let's get rid of this, we're going to have y to the power of, we're going to increase that power, so 3 over 2. So we've got y to the power of 3 over 2, and we want to divide by that new power. So dividing by 3 over 2, that's going to get messy. So instead of doing that, I'm going to multiply by the reciprocal. So we're going to have 2 over 3 times y to the power of 3 over 2 between 4 and 1. Now substituting that 4 in, we have 2 over 3 times 4 to the power of 3 over 2 minus, substitute the 1 in, so 2 over 3 times 1 to the power of 3 over 2, and we would end up with 14 over 3 units squared as that green area there. So that's one example of calculating the area of a region bounded by the y-axis.